Hello everyone, my name is Praveen, and today I'm back with one more topic in the microservices series. So basically, today we're going to talk about Docker, and this is going to be a course for mainly at the beginners level. So if you already have a little bit of experience on Docker, probably this particular lecture you can skip. And in this particular series, we're going to talk about the different commands in Docker, how to containerize an application, and all those things. So probably you can resume it from there. But you are at the very initial level in your Docker journey. This is a course for you. So thanks for tuning in to your own YouTube channel, Java Fun. And as if you're a regular subscriber, you must already know that we bring new and different technologies within the Java and the microservices world. And if you haven't gone through those, I will strongly recommend you to go ahead and have a look at it. Okay, so without wasting too much of time, we'll continue with our today's topic. So, what exactly is Docker, right? So, before answering that particular question, we need to understand why do we really need any technology like Docker. So, Docker is basically a technology to containerize your application, right? So now there are two terms. So there is a term that is newly coming to you, which is a containerization. We answer that what exactly is a Docker. You need to understand that what is the need for a tool like that. So Docker is a tool which has been designed to make build, deploy, and ship your application and run into any platform by using the containers. So this is a new term, right? So we need to understand what exactly is a container from developer's perspective, right? So to understand that, we need to take a step back, and then we need to understand that what are the problems that we face when we basically build an application in your local environment and then ship it out into different boxes. So generally your applications has been built onto the Windows environment, and then you build it out and then ship it on and run it on mostly a Linux or Linux like environments, right? If you are working on enterprise level firm, typically you must have seen that there are software version mismatches. There are mismatches in the way the OS works. Some of the settings are not working properly. So the application which was running perfectly fine into your lower environment, it doesn't work when it goes to a SIT or a UAT or even in the production. So how can we standardize or basically create a uniform environment for your code to work, right? So what are the ways to do that? So till now, before Docker, it's all manual. You wanted to make sure that the settings that you are promoting from low environment to higher environment, they are done manually, right? Then you need to basically sync those things together. Constantly need to make sure that if you tweak any particular parameter, software versions, everything, similar things has to be there into the right from your local to the production environments, right? So that is where the need for such application arises, right? Or such a tool arises, which will make sure that your application runs and executed in a uniform specific environment. So containers does allow developers to package not only an application, means not only your code, but all the things which is needed to run that particular code or software as well, right? So that typically maybe include your dependencies, or if you are from a Java background, you need some third party jars to run your application. You need a language runtime in Java, Python, whatever it is, right? And a specific version of that language runtime. Then you need an OS to run that particular application. So OS on which you are running your application has to be same, or you need to make sure that application is compatible with those things, right? So now containerization does allow you to formalize and make it uniform right from lower environment to higher environment, to build code, package, and ship the application as a single deployable unit. So that is where the Docker comes into picture. So it is created with developer and the ops in mind to make sure that everyone comes on the same page in terms of development and the execution of your software. Okay, so that is first thing, we understand where exactly and what exactly is a Docker, right? Now typically the standardization has been done using a technology called as namespacing. So on your screen, if you are reading the definition, it says that Docker is a tool designed to make namespacing easier. So namespacing is there in Linux, in probably since ages, right? So probably from a very early days, or not even in Linux, when its earlier avatar in Unix like OSs as well, this namespacing is there. Now, what does namespacing does, right? So namespacing does basically compartmentalize the processes which has been running in your application. So you create basically a wall or an isolation between the different processes. Now that processes may be your software, apps, anything which has been running onto your application, right? So why this compartmentalization needed? That is needed to make sure that you are creating a execution environment for your process to run. Now that execution environment includes a CPU resources, memory resources, hard disks, and any of the software which has been needed to run your application. And this compartment or the segment has to be created so that one segment doesn't interfere with other segment. In fact, one segment should not be aware of the others existence of other segments as well. So in our next lecture, we're going to go detail into what namespacing is. But for as of now, just think of namespacing to be similar to a creation of the compartments within your host or laptop box, Unix box, whatever you want to call it, right? So creation of a compartments, that compart for each compartment you are giving a CPU resource, memory resource, and all those things, so that one compartment doesn't know about other compartments and they execute into their own runtime. Right now, what are the typically I told you, right? Whenever you design an application, you basically design and create it in the platforms like Windows, and then deploy it into the Unix, Linux, Mac like an environment, right? So what are the problems that comes? Basically, if the environments are not consistent, the chances of it may break. Documentation may be a problem because the way you run application on Windows, those steps may differ from the way you run it on Unix kind of an environment. Typically now also, if you see, you go and find out any popular software, right? They will typically give you two different installers, Mac, Windows, two different instructions, how to install it on Mac, how to install it on Windows. So why do we need to maintain two different documentation, two different installation and instructions? Can we not standardize both of those things? Can we not make your software independent of the different moving parts? So the idea, the basic version or the basic takeaway that you can take from this particular lecture is Docker is there to basically minimize the moving parts needed to run your application. Basically, whether it is a language runtime, whether it's a hardware resources, whether it's an OS, or whether it's a third party jars that you need, right? So you need to make it consistent and reduce the moving parts. So you'll have a consistent build, deploy, and test environments, production environments, everything basically standardized, right? So that any change happen onto one particular deployable units, it will automatically be shifted into higher environments as well. As and when you deploy it into higher environment, you don't need to worry about propagating those changes from one environment to another environment, and to worry that it might fail or it will not work when it go to production, right? So all those things you don't need to care when you are building using the Docker. Now we talked about namespacing, right? So or creating a compartments or the segments. Now, what are the techniques by which those compartments or segments can be achieved? Now, there are two techniques basically. The virtualization and the containers. Now, Docker, as you know, in our definition only, we talked about Docker is a tool for containerizing your application, right? So Docker falls into second category, which is containers category. But what is exactly the virtualization? So if you are there in the software industry for a fairly long time, right, you must have known that there was a period when you used to install Linux on top of Windows, or you used to run a VMware softwares onto your machines, right? That is nothing but a virtualization. In a nutshell, I'm being too simplistic, but that is exactly what it is, without getting into the nitty gritties of how it has been implemented. So, to talk about the namespacing, right? So, there are two ways to implement it. One is compartmentalization in hardware or using the hardware, or compartmentalization using the software, and these two categories basically falls into these two things, right? By either you can segment it out using the hardware methodology, by segmenting your hardware and the resources, or you can achieve it by using software. So, and there may be a combination of one of those. So let's see how exactly the virtualization works, or what exactly is a virtualization, right? So if you see the definition which has been there, that it basically created to maximize the usage of your hardware resources, basically to use your physical machine to the fullest capacity. Now this is a very generic definition, right? So what exactly it means, if you're working in a enterprise level application enterprise level company, you must have come across, at least heard about it, is that there are, whenever you get any Unix box or something, right, or a Linux box, people generally talk about a physical machine and a virtual machine. So what exactly is that? So basically physical machine is an exact one machine, one dedicated physical hardware given to you, and you can log in into that machine and work it something similar to the way you do it in your laptop, right? Now what exactly is a virtual machine? Now virtual machine is exactly the same thing as that of virtualization, wherein you created a different segment within your physical machine and you give a different address to that particular segment, and then let allocate that particular VSI or a virtual box to someone else to use it, so that you are basically then segmenting out your resources. You are allocating a quota, so that how much memory, how much CPU one segment can utilize, and then give it to a different people, so that you are maximizing your physical hardware and how to utilize it. So that exactly it is exactly the same thing. Many of you must have already been aware of it, but this is the virtualization in a nutshell. So how it has been achieved, basically, right? So it has been achieved by using softwares called as hypervisor, right? If you have worked on Windows 2016 server or something compatible, or Windows 2010, you must have seen that it comes with inbuilt hypervisors, right? So what is an hypervisor? So hypervisor is nothing but a software which can be installed on a hardware, or it can be installed on a guest OS, and it basically helps you in creating those namespaces by using a virtualization technique. So if you are able to see this particular image, you see at the very bottom there is a hardware layer, right? On top of it there is a virtualization layer. So virtualization layer is exactly this hypervisor layer. So that is a software which has been installed on top of a hardware, and then you have installed two different guest operating systems on top of it. So I may have a Windows running in on the same machine, as well as I have a Linux running in onto the same machine. Both of them have their own applications, their own drivers, their own everything, right? And then you allocate a different quotas for each of those operating system to utilize. So that is how the virtualization works. Now consider this thing as a container. If you want to achieve the same thing using a software, that is where your Docker comes into picture. So we'll go into detail how exactly it happens. So this is a virtualization. The second thing is a containerization, right? So what is exactly is a containerization or the container? Container is a physical unit or a standard unit which is basically created to ship your software, your OS, your language runtime, application code system, tool system binaries, everything, and ship it out together and give it to someone to execute it, right? So that whenever they run this particular container, entire runtime gets created from ground up, which means including OS, language runtime, everything gets installed freshly every time you run it, right? And this is very lightweight if you compare it with virtualization, right? Virtualization, it's very heavy. First of all, it's not that performant compared to containers. So in the next slide we're going to look at the basic differences between the virtualization and the containers, because there may be a question in your mind, that those who are aware of the virtualizations and how to achieve it, why do we use a Docker? Because we are using the VM machines right from ages, right? So where exactly, or what's the benefit of using Docker? What benefit does it give us? So this is a benefit. This is differences between the VMs and containers. As I told you, VMs are very heavyweight. Compared to that, containers is lightweight, and because they are lightweight, they are extremely fast, and their boot up time is very fast. right? Now, VMs are basically they are hardware level virtualizations, right? So they are basically created keeping in mind to maximize the hardware level resources. But containers are created using the OS virtualization to maximize your OS will remains the same, and you are maximizing that and creating compartments on top of an OS. So if OS remains the same, what exactly that OS? So all the Docker containers are created based on the Linux or Linux-like operating systems. Okay, and it may be confusing because you must have aware that you can run Docker on the Windows as well. And in our this series also, we are going to run the Dockers on Windows machines. But when we go into the code, I will explain you what's the difference there and what how it has been running there in a Windows machine, right? Uh, since it is lightweight, again, it requires less memory. VMs are more bulky, requires more memory. Since the isolation happened at the hardware level, VMs are fully isolated and more secure because there is not easy to tamper between the processes to processes. And in case of containers, they are a little bit less secure because isolation is only at the process level and not you're not created the entire machine altogether the way we do it in case of VSIs on top of physical machine, right? So these are the difference between the containers and the VMs. Now, with this thing in mind, we'll move on to our next lecture, and will be where we'll cover in detail how this namespacing is implemented. What is the theory behind it? So next lecture would be a theory lecture. So even though you might not need it, but understanding the technology behind it will give an edge whenever you're working on a any technology, right? Any new age technologies, you need to understand the basic building blocks of it, and that is what we're going to cover into our next lecture. So thanks for tuning in. If you are coming here for the first time, we're going to cover this Docker in complete detail, even though the course says it is for beginner level, but all the aspects of Docker will be covered. So stay tuned. If you're not subscribed to the channel yet, please subscribe to it and press the bell icon. That is most important because next time I add a new lecture, you'll get notified. Thank you so much. Thanks for tuning in.